So here is a circuit, and I want to use the mesh current method in order to solve this. Recall that the mesh current method is based upon Kirchhoff's voltage law, or KVL. The mesh current method is based upon Kirchhoff's voltage law, or KVL. KVL states that the sum of the voltages around the loop is equal to 0. Another way of stating that is that voltage rises equal voltage drops. Voltage rises equal voltage drops. The other thing I want you to notice here is that we have a dependent source. A dependent source creates a constraint equation, and the constraint equation is based upon the controlling variable. In this case, the controlling variable is I naught. So that is a current controlled voltage source. Thank you, Donnie Don. That is a current controlled voltage source, where I naught, or I phi, is the current right here. So when I write these KVL equations, I'm going to also need a constraint equation. So first, I have 3 meshes. So the first thing I'm going to write is a KVL equation for mesh 1. I'm going to write a KVL equation for mesh 1. And I'm going to have that 1.35 is a voltage rise, and that's going to equal my voltage drop, which is 5 times I1 minus I3 plus 20 times I1 minus I2. Remember, anytime you have a resistor shared between branches, the mesh current is a combination of 2 different mesh currents. If it's an outer branch, then the branch current and the mesh current are the same thing. Thank you for sharing the live, Coop Coop. Thanks for coming to hang with us. Now if I do KVL at mesh 2, what about if I do KVL at mesh 2? If I do KVL at mesh 2, that's going to be my dependent source mesh. KVL at mesh 2 is going to be all voltage drops, so no rises, so 0 is going to equal 20 times I2 minus I1 plus 5 I1 plus 5 times I2 minus I3 plus 10 I'm just calling it I naught, even though I know that's really a phi, because I know some of y'all are not trying to be messing around with no Greek letters. Next, we're going to do KVL at mesh 3. KVL at mesh 3. When we do KVL at mesh 3, once again, we're going to have all drops, no rises. So 0 equals, look, 5I3, because that 5 at the top is an outer branch. So that mesh current I3 is the current through that 5 ohm resistor. So that mesh current and that branch current are the same. Thank you for tapping the screen. I did not make anywhere near 25,000 likes last night, and it really broke my heart. I think I barely got to 10. Let's see if we can knock that out the park tonight and actually make it to our 25,000 likes. Black History Month ends in an hour, so I'm not going to make my 25,000 followers goal. That's been my goal since January. We've now gone through January and I didn't make it. We've gone through February and I didn't make it. I don't know what that means. But we've got 6 people inside the STEM Cool Kid Club with us. We got 328 outside the STEM Cool Kid Club. If we can get these numbers to go up, I know I can make that 25,000 likes. Hopefully I can make that 25,000 followers. Black History Month ain't over quite yet. You can also go visit the TikTok shop and do all the amazing things to get us out on the FYP and keep us on the FYP. Once you become a member of the STEM Club, like Coop Coop just did, you now get access to my STEM emotes that you can put in the chat, because they are gorgeous. All right, let's keep going. So then I have 5I3 plus 5 times I3 minus I2 plus 5 times I3 minus I1, okay? All right, and that equals 0. I'm sorry, yeah, that equals 0, but I wrote the 0 first. So now, our constraint equation is a relationship between my mesh current and my controlling variable I naught. So my constraint equation is going to be I naught, which flows through the right, through that 5 ohm resistor. So I naught is a combination of I3 minus I2. Because it's I3 pointing to the right, it's I3 minus I2. So here are the corrections to the problems we were working on in our STEAM Saturday Live on the last day of Black History Month and the last day of Engineers Week. For the mesh current method, KVL equations, equation 1 is 5 times I1 minus I3 plus 20 times I1 minus I2, which equals 1.35. Equation 2 is 20 times I2 minus I1 plus 5 times I2 minus I3 plus 10 I naught equals 0. Equation 3 is 5 times I3 plus 5 times I3 minus I2 plus 5 times I3 minus I1 equals 0. And equation 4 for the controlling variable is I naught equals I3 minus I1. When you solve those 4 equations, you get that I1 is 4.32 amps, I2 is 4.59 amps, I3 is 2.97 amps, and I naught is negative 1.35 amps. So now that we have corrected our solutions to our systems of equations for the mesh current method and the no voltage method, we need to also correct our power balance table. Remember, our power balance table is based upon the law of conservation of energy that states that energy can neither be created nor destroyed, only transferred. Another way of stating that is power delivered equals power absorbed. So this first table is going to be for the mesh current solutions. The second table is going to be for the no voltage solutions. So for the 1.35 volt source, the current through it is I1. And so that means it is delivering power. So that's going to be 1.35 and 4.32. And the product is a negative 5.832 because that one is delivering. And then for the 10 I naught source, the current is 4.59. And the voltage is 10 times I naught, which is negative 13.5. So that one is also delivering power, negative 61.965 watts. resistors always absorb power. So first, for the 5 ohm resistor, I3 is 2.97. And the voltage is 5 times 2.97. Voltage equals current times resistance. That's from Ohm's law. For the 20 ohm resistor, the current is I1 minus I2, or you could also say I2 minus I1. So that current is going to be 4.59 minus 4.32. And so that's going to equal resistance times current again. Then for the 5 ohm resistor at the top, the current is I3, so that's 2.97. We just did that one. The 5 ohm resistor on the left, that's going to be 5 times I0, where I0 is 1.35. So this is going to equal current times resistance. And then for the next one, that is the 5 ohm resistor on the right, the current is I2 minus I3, so that's going to be 4.59 minus 2.97. And then the voltage. And you can see 4 times 10 to the negative 15 is essentially 0. So we have shown that power delivered does equal power absorbed.